Okay, so now here is 1.4. This is section 4 for first unit, which is dedicated to matrix and determinant. Unit 1 is dedicated to matrix and application. So now we are in section 4, and it is application of what we have learned, like matrix operation, like determinants, like inverse matrix, which is inversion is a unary matrix, and even transposition is a unary operation to solve simultaneous linear equation. So now we are in subsection 1, inverse of matrix. So and we have so this application, it can be applied, the inverse matrix can be applied in column-wise method or in row-wise method. So we will talk about, as we move on, we will see how these two methods work. Okay, now today this video is about application activity 141. Okay, so now activity 141. So what you have to find here is to find inverse of the given matrix A and matrix M. Okay, so now here, second question is about two matrices A and B, and we need to find inverse of one and the inverse of the other. Then we apply properties, inverse of inverse. Okay, here already we're gonna find that inverse of inverse is the matrix itself, and here inverse of a scalar matrix. So a scalar can be considered as a scale itself, so that a matrix itself, so that we will see some properties connected to this. Normally it is an application, meaning that we have talked about all properties needed to work out these activities. Okay, so now starting with the first question of this application activity. So this is okay. How can we work this out? So let us use this space matrix A here. We are going to find its inverse, and then let us use the space here. Okay, this is space. Okay, so for the first suppose the first matrix A here. So we are going to deal with the question 1. So we have sub-question A, and okay. So we, in general, we take any matrix of A11, A12, A21, A22 as coefficients, and then after calculation using different methods, we have its inverse is 1 over its determinant multiplied by the main diagonal elements are reversed, are exchanged, and the non-main diagonal are opposite of themselves. So A12, you take opposite, and you have A11 here. So there are different techniques that can lead to, as you have seen, and as we have studied, which can produce its inverse like that. So in this case, we can, using this formula, we can find matrix of A here. So it is equal to 1 over determinant 26, 5, 2 determinant, and then we exchange main diagonal element 220, 22 becomes 220. So negative 6, 6 becomes negative 6, 5 becomes negative 5, and then this is equal to 1 divided by 20 times 2, 40. 40 minus 5 times 6 is 30. It becomes 1 over 10 times 2, negative 6, negative 5, 20. So this is 1 over 10 multiplied by 2, negative 6, negative 5, 20. Okay, this is the inverse of matrix A in this case. Okay, so now so we will see some application of this inverse matrix in order to solve simultaneous linear equations. Okay, so now next, some question A is answered. Okay, let me just keep the answers here for all to see. So question A, so the inverse of 25, 6, 2, inverse is 1 over 10 times 2, negative 6, negative 5, 20. Okay, so now we need to look for the second question. Question B, sub-question B, actually. So this sub-question B may take a bit longer because it is a 3 by 3 matrix, depending on the method that we are going to use. Okay, so here, let me just use rewrite this matrix M. This is 5, 3, 2, 0, 4, 1, 2, 5, 2. Okay, so now suppose the question in sub-question B is to find, what we want to find is to find the inverse of this matrix. Okay, of course we are going to use some formula like 1 over determinant of M. We use the cofactor matrix of matrix M times C11, C12, C13, then C21, C22, C23, C31, C32, C33, and we take transpose. And in that case, if we get this matrix, this is the cofactor of the coefficient 5, and so on, depending on each coefficient here. And then, after finding this matrix of cofactors, we're going to find the transpose. But first of all, let us find the determinant of matrix A. So the determinant of matrix A, M, not A. So let us develop along the second column. So we will have, so 0 we don't care, so negative 4 times 0. So this row we move 5, 2, and 2, 2. So after removing the first column and the first row, you get wait, 3, 5. No, it is so we'll move this one. No, it is for this coefficient with the negative sign, negative 4. So we move the second row and the second column in order to get 5, 2, 5, 2, and 2, 2, 2, 2. Okay, maybe I will continue with a different color. So now with the 1, it will be positive 1. So times Z. So times z. If I remove the third row and the second column, I will be left with 5, 2, and 3, 5 determinant. So in this case, I will calculate this combination, -4 plus 10 minus 4, and 10 times 5 times 2, 2 times 2, so it is equal to 4, and 10 out of 10. So now plus 1 times 25 minus 6, and I'm gonna get the determinant. This one will be -4 times 6 plus 25 minus 6 is like 19, because 19 plus 6 is 25, and then I get 24 plus 19. 24 plus 19 is like 41. Okay, this is not 41. This is okay. Let us see. 6 times 6 is negative 21. So now 21 out of 19 is equal to what is it? Is equal to 5, and I am left with 1. Now I change sign and I get -15. In this case, this is the determinant. So which means that the determinant of this matrix is equal to -15. This is -15. Negative, because this is -24, 19. No, it is not, it is just 5. Okay, -5. Okay. This is it. Yeah, mistake here. So -5. Okay. This is the determinant M. Now we are going to look for this cofactor. So cofactor number 1, it is -1 times 1 plus 1 times z. Now I move this one, get 4, 4, 5, 1, 1, 2. So out of the matrix M, so this is equal to okay, this is equal to 1 times 4, 8 minus 5, which is 3. So next 1, 2, this is -1 power 1 plus 2 determinant. So this is factor of 0. Remove this and that. 3, 5, and then 2, 2. So this determinant is opposite of 6 minus 10. 6 minus 10, -4 plus times -1. It's going to be it's just okay. Let me just use this space. This is -6 minus 10, which is equal to 4. So C1 1, 3. So this is equal to -1 power 1 plus 3. So determinant I'm looking for is 3, 4, 2, 1. 3, 4, 2, 1. So this will be 3 minus 6, which is -3. So finally, so we have 1 over -5 determinant. So now I'm gonna find first cofactor 3, second one is 4, third one is -3, and I'm gonna get the transpose of this matrix. So let us look for the second row, that is C11, C12, C11, C12, and C13. It is just -3. Okay, now as we have this coefficient 3, 4, -3 here, it is saved. Now we are looking for the second row of this matrix inside here, and that is, of course, here we look for C21. So C21 is going to be equal to -1 power here 2 plus 1 determinant of 0 2 0 2 and 1 2. So this matrix is negative 0 minus 2, which is okay. In order to save space, I'm going to write it over here. This is negative 0 minus 2, which is 2. Now C22 is equal to -1 power 2 plus 2, determinant of 5 2 and 2 2, because we are looking for a factor of 4, a factor of this middle coefficient on diagonal. So this is going to be 10 minus C. Okay, this is 10 minus C, and this is 6. C23 is equal to now -1 power 5. 2 plus 3 is 5. Now determinant, as I'm located here, a factor of 5 is going to be -1 times matrix 5 0 and 2 1. And this is opposite of 5 minus 0, which is -5. Okay, so this is the second row, starting from 2 1. 2 1 is 2, 2 2 is 6. Now 2 3 is -5. And next we look for the third row. We look for third row. So third row is C31 is equal to -1 power 3 plus 1, and then determinant of 0 2 4 5, which is 0 minus 8, which is -8. So -8 can write it over here in order to save space. Next, I have C32, which is -1 power 3 plus 2. Determinant of here. So I have 5 2 3 5. 5 2 3 5. So I'm gonna get negative of 25 minus 6. 25 minus 6 is 19. Let us check again. I'm here and here. Then I have 25 minus yes. This is negative 19. Okay, I hope it's correct. Now the third component is -1 plus 3 plus 3. Determinant of this one and this one. We have 5 0, 5 0, and 3 4. Okay, so now this one is going to be equal to 20 minus 0, which is 20. So now the third row is -8, then negative 19, then negative, then 20, then 20. So this is a matrix from which I'm going to take the transpose of it. Okay. Let us take the transpose of this matrix by taking the transpose. We have M inverse is equal to 1 over negative 5 according to this formula. So now transpose of this 3, 4, negative 3, then 2, 6, negative 5, then negative 8. Transpose of this row is negative 80, negative 19, and 20. This is inverse of matrix M. Now we can check if it is correct. Times M is 1 over negative 5 times so times 3, 4, negative 3, 2, 6, negative 5, negative 8, negative 19, 20. So I'm gonna multiply by 5, 0, 2, 3, 4, 5, 2, 1, 2. This is equal to 1 over negative 5, and then let us multiply 15. 15 plus 6, 21. Now minus 16. 21 minus 16. 21 minus 16 is negative. It is negative 1. Wait, here we have 15. 6. 21 minus 15 is positive. So what am I doing? Yes, negative 16 out of 21 is 5. So this can't be, since determinant has been calculated to be equal to negative 5. Now, probably we have some mistake that we have to correct after calculation. So 15 plus 6 is 21, minus 16, it is equal to 5. That's correct. Now 0 plus 8 minus 8 is equal to 0. Next, 6 plus 10 is 16, minus 16 is equal to 0. Now 4 times 5, it is 20. 20 plus 18, it is 38. 38, no, where am I? First, it is second row. 4 times 5, 20. 20 plus 3 plus 18 is 38. 38 minus 38 is gonna be 0. That's correct. That was what I was looking for. Okay, now next, 0. 6 times 4, 25. 24. 24 minus 19, it is 5. Okay, now next is now 8 plus 11, it is 19. 19 minus 38, what is it? Okay, so here I have to check this one. Okay, let me check correctly. This is 4 times 2, 8. 6 times 5 is 30, 38. 38 minus 38 is 0 correctly. So now negative 3, 5. times 5 is negative 15. Negative 15 is 30. 30 is negative 13. Negative 13. And 20 times 2 is equal to what is it? Is equal to 40 minus 30. 30. 40 minus 30 is so what am I doing here? Okay, is the what is this? Okay, so let me check what I have written if it is correct. So 3 for negative 3, 2, 6, negative 5, correct? Negative 8, negative 19, 20. So 20 was the last cofactor. Let me check this. Maybe I have some mistake here. So this should be removing this and this. I'm getting 20. It is exactly 20 in this case, so there is no mistake. Okay, now let me just look at this matrix. This product, it is negative 15. Oh, let me use another marker pen here. For example, this one, so it's going to be equal negative 15. This times this, and this times this, negative 15. And then 10 times 2, it is 40. So this is 10. So this is not possible. Since we are looking for something is wrong. Something is wrong. It is wrong. How can I fix this? Possibly the second row is where there is a problem. I have to check. So I checked for this. This is correct. I checked for this. So I have to check for. So I have checked for this one. So I have to check because the last row, no, the last column of this matrix is what is the problem. So I have to check this one, negative 5. So how is it obtained? By removing this and this and this, get 5. That is correct. That is correct. And there is a negative. Now I have to check negative 3. This one and this have 3 times 1 is 3. Minus now 8. 3 minus 8 is 5. So instead it is 5. 3 minus 8 is negative 5. So now after transposition, I have negative 5 here. That is where we have problem. So now I revise 5 times 5. So I'm going to find this one. I check again. So 5 times 5, negative 5 is negative 25. Negative 5 times 2, negative 15. Now 20 times 2 is going to be, I'm here, 20 times 2 is 40. Okay, that's 0 and it's correct now. I have 0 here. So which means that this matrix, from this matrix we have its inverse. Here we are checking, even though there is still a problem, but I'm gonna fix it at the end. I don't want to lose this video. Now, what is next is to take this row times this column minus 5 times negative 4. It is negative 20 plus 20 is 0. Now, negative 5 times negative 2, negative 10, negative 5, negative 5, negative 25. Now, 20 times 2 is 40. So now this is the result is 35 out of 40 is 5. Okay, here is 5. Now the question is, as I have calculated the determinant and found negative 5, probably somewhere I was wrong, and it should be positive 5. The determinant should be positive 5. And now we can check for it, because possibly somewhere I was wrong. So I have to check. Somewhere in the determinant there was a miscalculation. So let me recalculate it again. This is 5. Now I start by so this is 0 I don't consider. I consider negative 4 times that is not negative 4, it is positive. But where lies the mistake? Because minus positive minus, so positive 4, so times now 5 2, then 2 2, now 5 2 2 2, yes, now minus now this coefficient is 1, and I multiply by this is 5 2 3 5. This is the determinant that I'm looking for. Is 4 times 10 minus 4 minus 25 minus 6 results. So 4 times 6 is 24 minus now 19. So this is 25 minus 6 is 19. So out of 24 is equal to 5. So reason why we have positive 5 instead of being negative 4, negative 5. So the result now, I'm sure of this result because the product m inverse times m is going to be equal to this scalar matrix, and this scalar matrix is exactly equal to identity matrix of order 3. Okay, now I'm sure that the inverse, this inverse is positive here. It is the inverse of the matrix M here. I am sure. Okay, that was the sub question B of the first of the question 1. Now here, now we are going to look for this matrix A and B. Possibly they are invertible matrix because they are talking about their inverses, and then from here let us now work out I, double I here, so 2 here. So this matrix, it is very easy according to properties. Inverse of inverse equal to matrix itself. So we don't need further calculation. Now here, inverses of product of two matrices, like suppose B and A, for example, the inverse is inverse of A times the inverse of b in reverse order. So in that case, if we take, for example, b, take b like 10, so inverse of 10 is going to be 1 over 10, which means that in this case, what are you going to do? You're going to take b. If we take b as 10, so inverse of 10 is 1 over 10, and then so we have inverse of 10. No, so we use the formula. Formula is to take inverse in reverse order, which means a negative 1 times 10 power negative 1. So this is 1 over 10. This is scalar. It may commute with any matrix. 1 over 10 times inverse of A. And here, inverse of A is going to be calculated in I. So meaning that we have already answered 2 and 3 i's. So now I, the first I, we need to calculate the inverse of this 3 by 3 matrix, and B also is the 3 by 3 matrix. Okay, now I think that it will be a great job to leave this space and find space here in order to, oh, okay, this mistake is still there. This is positive 5. Everything else is okay. Also, possibly this number, no, this is okay. This is okay. No, the inverse is, we have corrected here. It should be negative 5 here instead of negative 3. Okay, this, I think everything is now clear. This is M inverse, this is M. Okay, with that mistake, we remove that mistake. Let us use a color different from this one. This is what is negative 5. Okay, determinant is 5. Okay, it is corrected. So now let us move to our next point. Next point is to find out inverse of A here, and also after that we're gonna move to the inverse of B. Okay. Okay. So this is great. So far, so good. Now let us now think about how we can now calculate the, first of all, determinant of H. We are looking for 2 I. So we work out I because 2 and 3 has been resolved here. It's okay. This one is okay. We are going to work on this one. So determinant of this matrix 3, 7, 2, 1, 0, 2, 0, 1, 1. Okay. Now there is a way of finding determinant. If we can make it, if it's possible, we can make it a triangular matrix. It will take a little bit, a bit longer. So let us calculate as usual. I can develop this through the second, the third row. The third row here, 0, 1, 1. Then I will have determinant negative because I have negative positive. So I have now positive negative, negative times 3, 2, 1, 1, 2. Positive here. Then I have 3, 7, 1, 0. So that we have negative 6 minus 2. positive 0 minus 7. So this determinant is going to be equal to 4 minus 7 is equal to negative 3. 4 minus 7 is going to be negative 3. That is the determinant of the first matrix A. Okay, so now let us now find the the second question 1. So determinant is this negative 3. We are still working on question 2. So question I. Now let us look for cofactor matrix, and after that we are going to look for the transpose C13, C21, C22, C23, C31, C32, C33, and we take transpose. Again, let us start by C11. So using this matrix, so 311 is going to be equal to positive determinant of 0, 2, 1, 1 is going to be equal to 1, 1 is going to be equal to started over here. What here? Okay. So 0 to 1, 1. So now this is 0 minus C minus 2. So C1, 2. So I'm here. So I'm going to have negative 1 and 1, 2, 1, 2, 0, 1. So this is going to be negative 1. This is going to be negative 1. So C13 is going to be from here positive 1 times of 1, 0, 0, 1. So this identity matrix determinant is 1. So, but at the last one, positive. So now it is 1. Okay, now here I can substitute these rows by the corresponding value as we have calculated. This is negative 2, then negative 1, then 1. Okay. So now looking for the second row. For the second row, so we have C21 will be negative determinant of looking for this matrix, this one, this row removed, this column removed, 7, 2, 7, 2, 7, 2, and 1, 1, because by removing this row, and this column, we are left with this, and by after calculation, 7 minus 2, this is negative 5. 7 minus 2 being 5, take negative 10, coming from the powers of negative 1, which is odd power resulting in negative 1, then C22, we have a positive power of negative 1, and here I'm removing this row, this column, left with 2, 3, 2, and 0, 1. After calculation, we have 3. C minus 0 is 3. So lastly, but not the least, in this second row, we have a negative power of 1, is odd power resulting into negative 1. And then I have to remove this column and this row. I'm left with 3, 7, uh, 3, 7, and 0, 1. Excuse me. Okay, so now result is going to be equal to -3. Okay, so now we are having this row, second row. Let us remove it. Okay, now I will have -5, 3, and -3. Third row, also let me use this space. I'm going to find C31. It's going to be a positive power of 1. It will be an even power of -1. It is 1. Then determinant of 7202. So it's going to be equal to 14. Okay, now C32. So now it is negative. It is a node power of -1. So here we will have this row removed and this column removed. We are left with 3, 1 and 2, 2. So result is -6 minus 2 is -4. Because 6 minus 2 is 4, we take a negative sign. Then 3, we have an even power of -1. We have a positive determinant of so I remove this column and this row. Third column, third row, I'm left with 3, 7 and 1, 0. 1, 0. Result is I have -7. Okay, so I replace this row by 14, -4, and -7. Okay, I think it's correct. Cofactor of 3, 1. Cofactor 3, 1 is this. Yeah, I think it's correct. I move this and this again, 14. Okay. So now I remove these results because they have been recorded here. Then I'm looking for the inverse of A, which is 1 over determinant A times the transpose of this factor matrix, and this is 1 over determinant. What was the determinant? I think it was we deleted it by mistake, but it was calculated to be equal to if I remember -3. So no matter, I'm going to check if it is really determinant, if it is really -3. So now we have transpose of this. First row becomes first column, second row becomes second column, third row becomes third column. Okay, so this is inverse of matrix A. So we had some problem about the determinant of A. Now we are going to check in order to fix if there is any mistake. We take A inverse times A, having 1 over -3, factor of -2, -1, 1, -5, 3, -3, 14, -4, -7. We multiply it by 3, 7, 2, 1, 0, 2, 0, 1, 1. In order to find 1 over -3. Okay, so here comes where we are going to check whether there is some mistake, possible mistake. Negative 2 and 3, negative 6 minus 5 is negative 11. Okay, here is for sure we have so many mistakes in here because this one is not giving negative 3, so negative 6, negative 5. So that means that we have a lot to be discussed about the possibly, because we have this row and this column, this negative 6, negative 5 is negative 11. So in order, either we had some mistakes on the cofactors or on determinant. So better is to check the determinant. I cannot go back to check the determinant of this matrix. Okay, so how can I check this? Okay, let me continue with the other. This first row, 2 times negative. So now let me continue here. Negative 4, negative negative 10. It makes negative 14. Then 14 you have 0. Oh, okay, now negative 2. So what am I checking? No, this is for the last one. Negative 2, negative 10, negative 14, 14, 0. This is the third row, the third element in the third row. So in the second, negative 14, so 0, and then 14 is 0, 2. Okay, so let us continue. Now, negative 1, negative 3, 3, positive 3 minus 3 is going to be equal 0. So negative 7, so this is 0, and negative 4. So this will bring negative 7 plus 3 is negative 4. Really? Negative 4, negative 7. Now 0 and negative 4. So this is negative 11. Okay, very good. So now negative 2, positive 6 is 4, minus 4 is 0. Okay, so now here is 3 minus 3 is 0, because negative 7 times 0 is 0. Now next, 7 minus 3, 7 minus wait, this is this row times this is 7 minus 7, it is equal to 0. Okay, that's correct. Now next, we are going to deal with 2 minus 6 is minus 4. So now minus 7 minus 7 minus 4, it is negative 11. So I think once again 2 minus 6 is negative 4, negative 4, negative 7, negative 11. Correct. So which means that probably and for sure the determinant, the main determinant of A is what is wrong. I thought it will be negative 11. Let us try again the determinant of A. So I develop once this time the first column 3 times 0, 2, 1, 1 minus this 7, 2, 1, 1. Okay. This is 3 times negative 2 minus 7 minus 2. This is now negative 6 negative minus 5. So this is negative 11. Okay, maybe I didn't remember what was the determinant. Now determinant here is not equal to negative 3, but the determinant is exactly equal to negative 11. This is the determinant. Okay, so now from this activity, because so we have this one, so we can correct this mistake now. This mistake, it should be negative 11. So in doing so, we have this is becomes negative 11. This becomes negative 11, and when we multiply, we get identity matrix, which means that our inverse finally, let us calculate it over here, save it like here. So inverse of here, inverse of A, inverse of A is equal to, so multiplying here, everything that is negative becomes positive, 1 over 11, 2, 5, negative 14, 1, negative 3, positive 4, negative 1, negative 1, positive 3, positive 7. So meaning that everything that was negative becomes positive upon multiplication on each coefficient by negative 1. Okay, I think that is pretty much good for the inverse of matrix A. Now, moving on to, let us move on to the inverse of matrix B. In this case, is it? That was after transpose. That's okay. I think it's okay. Now, okay, once again, what we need is matrix coefficient for B, cofactor matrix 1, 2, 1, 3, C 2, 1, C2, 2, C2, 3, C3, 1, C3, 2, C3, 3. Okay, so also we need determinant of matrix B this time. So we can expand. Okay, here we can expand by the last row. This is negative 1 times determinant negative 2, 1, 1, 6, negative 1. Now 2, 1, 3, 6, positive 1. Now 2, negative 2, C1. Okay, this determinant is negative 1, negative 12 minus 1, minus 12 minus 3, positive 2 plus 6. Okay, this is the determinant upon calculation. We have negative 13 coming from negative 12 minus 1. For fear of losing again the true value of determinant of P, let us recheck a bit. This one is negative 2, 6. Yeah, that's okay. Moving on, minus 9, positive 8, which is save this determinant somewhere. Is 12, positive 12. Now from this time on, I'm going to calculate the cofactors. So C11 is going to be, the matrix is here, is positive 1 times 1, 6, 1, 6, 1, 1. So this is going to be equal to 1 minus 6 is minus 5. Okay, C12 is going to be equal to the determinant 36 negative 1 1. Okay, so this is going to be equal 3 plus 6 is 9, negative 9. C13 is going to be equal to determinant of C1 negative 1 1. So that is 4. 3 plus 1 is 4. So now I'm going to substitute this value. So negative 5, negative 9, and 4. Okay, the second row, this time it has hope. There is no mistake again. Okay, so now C221 is negative row. Determinant of, I think I'm here, determinant of negative 2 1 1 1, which is negative 2 minus 1, negative 3, positive 3. Okay, C2, C2, so this one is positive what, and here that is 2 1 negative 1 1, 2 1 negative 1 1. This is 2 plus 2 plus 1 is 3. Okay, this is okay. They are same. C23 equal negative 1. Here and here we have 2 negative 2 and negative 1 1. So result 2 minus 2 is 0. 2 minus 2 is 0. So regardless of the sign. So finally we have these coefficients will become 330. Okay, now next let us calculate in this case let us calculate C1 is going to be equal to determinant negative 2 1 and 1 1. No, yes, no, this and we are at 3 1. So we should remove this and then negative 1 1 1 6. Yeah, this is negative 13. C32. So now we have negative sign, and we're looking for removing this and this. We have 2136, 2136, and it is negative 13, negative 12. 12 minus 3 is 9, 9 negative 9. So C33. So we have determinant removing this and this. 2 negative 2, 3 1. 2 negative 3 1, yes. Result 2 plus 6 is 9. So 2 6 is not 9, of course it is 8. 2 plus 6 is 8. So coefficients here, is negative 13, negative 9, and 8 in this case. Okay, now the inverse matrix is now going to be equal inverse of B. This matrix, its inverse is 1 over determinant of B times the transpose of cofactor matrix. This is 1 over 12, negative 5, negative 9, 4. First column, second column, 3, 3, 0. Third column, negative 13, negative 9, 8. Okay, this is the inverse of matrix B. But as I'm not sure if those calculations are correct, I have to checking if negative times power inverse times the matrix B, if it is identity. So I will have 12 here, negative 5, 3, negative 13, negative 9, 3, negative 9, 4, 0, 8. Then I multiply by 2, negative 2, 1, 3, 1, 6, negative 1, 1, 1. Okay. So over 12. Now, the first test, if I multiply this one, I don't get 12. So I'm wrong somewhere. It is negative 10, positive 9, plus, so negative 10 plus 9, and positive 13. What is it? It is 14. So which is wrong? No, not 14. It is negative 1 plus 13, which is 12. 12. That seems to be nice. Good. So negative 10, 9, negative 1 out of 13 is 12. That is pretty much good. Now next, let us see if this is positive 10. This is 3. What is it? It is positive 10. This one and this is 3 minus 13. That's 0. Next, negative 5 plus 18. Negative 5 plus 18 minus 13. What is it? So that one is 13 minus 13 is equal to 0. So let me use the second row times this. This is the thing. Let me use this space. So I have second row, negative 18 plus 9 plus 9. It is 0, first correct. 18 plus 3, then minus 9. This is, it should be 12. So that is 18 minus 6. This is 12. 12, that is correct. Now next, let me just once again, look for this row times this column, negative 9, positive 18, negative 9. This is 0, obviously. So last row, let us work on last row. 4, negative 8, positive 8, 0, What did I use? No, I used this. That's correct. That's 0. Because 0 times 3 is 0. Okay. Now next, let me move, because we have this 0 to help us to speed multiplication. 8 then plus 8. This is also 0. Now come on 4 plus 8. This is 12. So which means that our calculation before to find this inverse was perfect. So reason one, in this case, we have inverse of matrix B is equal to 1 over 12, factor of negative 5, 3, negative 13, and negative 9, 3, negative 9, 4, 0, 8. Okay, so now this is very interesting, but it has been a long calculation. But finally, we have it. And with this, we have come to the end of this video. I hope you are going to enjoy it. Thank you very much.